is an essence of life. It is a necessity for every living thing to drink water in order to survive. Winneba is one of the communities that depend gravely on water supply for their daily activities.
So basically, this is Winneba Headworks treatment plant, and we are apparently at the Winneba intake, where the raw water is being extracted to be treated at the headworks. So this is the river Owusu, the river you're seeing, and this is the dammed water. We dam the water. Why do we dam the water? We dam the water for future use. During Harmattan season, November, December, where there is drought season, you don't have this excess water flowing over. This is the excess water going into the sea, right? Now, during November, December, you don't see this. So the excess of the dam is that when we dam the water, it gives us hope. Short period during the drought season, we have excessive water to be able to treat for our consumers. So Owusu, as we know, is a bit pristine. It's a bit clean. However, I could see that this water is very tepid. However, the turbidity of the water, comparing to yesterday, what we had in the lab, this doesn't contain any galamsey ingredient. It doesn't contain mercury. It doesn't contain that. So I could just say that because the water from upstream is tepid, that is why this water is tepid. So apparently in the lab you could record a color of 400, 600. This is about 12 feet down. 12 feet. 12 feet is like twice of me. Or no, I'm like 6 maybe 5 point something feet. So 12 feet will be maybe 2.5 of me or something. So that is how deep this is. So here is very deep. But then there are two things that goes on here. We have two tunnels here, one at the middle and one at the bottom. When the water is at its high peak like this, the water is drawn from the top to the pumps. The pumps draws from the top. Why is it so? When the water is like this, all the dirt or all the suspended particles goes deep down. Therefore, we are able to draw from the top. When the water goes off and the water goes down in the drought season, Harmattan season to be specific, this water will come so down. When it comes so down, we cannot use the top again. We would have to use that from beneath. Do you understand? So that is what goes on here. Now, in addition, we have strainers here. They are called strainers. Strainers, they are like sonnier. In tree, we call it sonnier. When you are doing your Murphy, that's how they look like. We have two. We have bigger one and a smaller one. The bigger one take care of the locks or bigger particles in the water. It keeps them from entering into the pump. Now those tiny ones, which may as well tarnish our pump or clog our pumps, those tiny strains or sieves take care of that. So we have general workers or divers who dive in here maybe once a month to take off everything that has choked the sieve. So there's a pump there which siphons the water from here through to the treatment plant. I think in the year 2023 there, 2022, 2023, this place became so dry. It became so dry to the extent that we were treating water intermittently, right? Yes, the water we're treating to was intermittent. Maybe today we'll treat water, tomorrow there will be no production. We are waiting for excess water to come from upstreams to fill the dam before we could extract to treat to you. So during those times there were intermittent treatment of water. But after those times I've never experienced that. Owusu River comes directly from here, directly to this place, due to the pumps. That is the intake pumps which we're using at the intake. So now this here is the same raw water which you saw, which was dammed. It's what is coming here. So now apparently here, what is going in here is called aeration. The aeration processes are more. We have double cascade, triple cascade, or single cascade. This is called a single cascade aerator. So basically, that is what goes on here. The aeration helps to take away the odor from the water. The reason why we're doing this is because we want the odor from the water to be expelled or to be excreted from the water. The water you are seeing here is the same raw water you've seen upstream. There's been nothing added. Now, what we are apparently adding here is the alum, right? The alum is a form of coagulant. This alum, aluminium sulfate. The aluminium sulfate helps in a process called coagulation, right? Coagulation is a process whereby the dirt in the water is eliminated primarily. And then the Emma is saying, how it was so we that is what the alum does. Now wait, the alum does not get rid of suspended particles necessarily. Suspended particles are they can easily settle. That is not the main aim of the alum. The main aim of the alum is to make sure that colloidal particles are get rid of the water. Colloidal particles are for instance, when leaves decay in water, they leave color in the water. Those color are not easily expelled from the water. No, you need a coagulant. You need a chemical, right, to make sure that those chemicals get rid of it. But substance just as soil, leaves, and all those, they are suspended particles. Or making us suspended when the water is stagnant for a bit. But colloidal particles, for instance, pouring the milk into water, no matter how long it waits, the milk can never suspend. It will stick in it forever. So those particles, the colloidal particles, are what the alum is aimed at getting rid of. First one is aeration. Aeration is the removal of odor. The second one is the coagulation. Coagulation is the removal of what? Color by the use of coagulants. And I said apparently in Winneba headworks, we use alum and polymer as our primary source of coagulants, which helps to take off the color from the water to make the water aesthetically pleasant. Now the third procedure, which is here, is the flocculation chamber. When the alum is placed in the water or is dropped or injected into the water, right, you must gently stir it to make sure that the flocks are formed uniform, right? So that the flocks will not disperse, will not scatter. And we want flocks to become uniform, so that they become so dense to the extent that they won't settle. So now this procedure helps us to achieve that. This is called the flocculation chamber. So look at how it is designed. The water enters here, comes here, goes there, comes here, goes there. So there are air. So it is in a serpentine movement. So it is in a why is it so? It helps to gently stir the water. Because this one helps slowly. So while this is going on, it is helping to gently stir the water. And the main aim of introducing the coagulant or the alum is that the per se a fina a walk winning any alum alum channel. Not a feeling a denser. You can't say be a denser, meaning the thing is heavier than water. Not anything sink down. This is the sedimentation water we saw there. You can see that apparently here the water is very clean, right? Even though you can see tiny flocks in it, but it is not as dirty as what you saw in the flocculation chamber. So this water is now being decanted. This is called the decanting trough. This is the onsensorial rim. So it's called the decanting trough. So the decanting trough is collecting water. It's a collector. It's collects the water into the filter bed. So these are the filter beds. So 1, 2, 3, 4. So this decanting trough is collecting its water into its filter bed. You understand? And so that is how it works. So after the sedimentation process, the next process is what? Filtration. Now, what is filtration? Filtration is a process whereby every sediment is taken out of the water. And I mean every sediment is taken out of the water. And to say that flocks This filter bed is designed to trap every sediment from the water. As of now, there are no collider particles in the water because we should say crunching nice. There is no color in the water again. And what gives rise to the color is the collider particles, right? So now, collider particles they sediment can occur. Now, these sediments are being taken from the water by this filter bed. Winneba headwards, this place is the highest level in the whole of Winneba. That is why the plant was seated here, right? It wasn't seated down there. Because and it would have been easier for us to treat the water down there. But this place is the highest level in Winneba. In other words, whenever the water comes here, we don't use energy to distribute the water to your homes. It flows by gravity. So we don't pump the water from here. From this level, we just release the water, and the water goes to South Campus. It goes to Low Cost. It goes to Roman and all that. Now, when you cast your eyes, you can see the overhead tank. Tank in our honor. 2 tanks. That overhead tank. We have a pump in this room there. This pump pumps water from here to that place, and then it distributes water to people at Jinjinazi, Atetu, and part of Breku. Why do we do that? But the gravity here, when we release the water, ain't me could do it. But when we lift the water so high, at a higher apex to that higher tank, it has that tendency to be able to reach that levels. Do you understand? So basically, when the water gets here, the water is released to town by gravity. But then there are some aspects of town, because of the topography of their area, that is the landscape of their area, we have to pump to those places. And then there is one place where we can't pump it to them, or we can't release the water to them unless we pump. That is Pomade. Pomade is after junction. Because of the topography of the area, unless we pump from here directly to those places. Because when we release the water to those places, it only goes as far as Town Hall. So we developed a strategy to make sure that the water still goes to those places at Pomade and New Winneba. And these strategies helps us to save cost. So the reason why the treatment center has been cited here is because of cost. After treating the water with all this chemical cost and all that, we can just release the water to town with no cost, right? And so now the basic challenges we face as production staff or as what Ghana Water Company production is that there are times that we get challenges on our pumps. That is our intake pumps. Whenever our intake pumps get spoiled, we aren't able to pump water to town. Secondly, when we have challenges on our plant, we have a problem with our sedimentation tank, we can't produce water to you. So meaning production has to come to a halt. Do those maintenance works before producing water to you. So at times, when you have intermittent flow of water, in other words, when you don't have constant flow of water in your homes, it is because of perhaps maintenance work that is ongoing at the treatment plant. Do you understand? There are times that it may not be from us, but from the distribution sector. The distribution sector are those who takes care of the mains, the pipelines that comes to your homes. Perhaps there is the best around your area. And so when there is the best around your area B, so area A may have water, but area B, which is your line, may not have water. And it is because of that first. So perhaps you may make a call, and then the distribution team may come to your help or may come to your aid, do those maintenance work, and then water will begin to flow. So these are the challenges we have in our treatment and then distribution that may prevent you from getting water. So basically, Ghana Water Company, that is what is that.